Manjunath. So I'll be presenting here the deep learning course assignments of the class happen. So in this assignment, I'll be presenting the Keras Hub and Teachable machines collab, where so the basic assignment it will be distributed in the two parts. The first one is using Google Teachable machines for the image, post, and mm, text classifiers, and the part two assignment is of applying Keras submodels for the both image and the text as a different complexity levels as for example easy, medium, hard, and etc. I'll be presenting both the files like in the upcoming sessions. Yeah. So this is the file where like I performed the teachable machines demo. uh, let's first part to starts with the image classification model where it will detect the image versus object classifier for the TensorFlow capabilities. And the first one we will be presenting the machine model, and it shows the correct predictions because human face and other features, etc. So here if you check the image content is loaded and the pair is happening the prediction of the classes, where this is the predicted human confidence, that is it has a one ratio, that is a human, and it's a bottle, so its a confidence level is one for the bottle object detection. So this is the first one, and this is the video based post classifier for as the loading the model for lightning 4, and this is the model which was downloaded on the teachable machines, and these are the files which are the force standings for example this is the force for the standing, and these are the forces for the arm raise and other things. So this is the example for that. And if we move on to the next is the text based classification model. So in this like I'll be loading the uh, TF hub, that is Universal Sentence Encoder 4. So with this, like it was able to understand the text and what was the context like embeddings in this happen. So here is the like, clarity for that, like whether the model is positive or the logical model on positive or negative sentiments, and it's accurately classifications example of sentences and other things, etc. So this is about the teachable models. And next if we move on to the text based models and image based models. So first we'll go to the image based models, and this is the easy level. So like in the easy level, like I used a MobileNet v2 from TF hub with a dense layer to classify the inside per digits and other features. And if you go on to the next session is the intermediate level. So in this like I use this CNN trained KMNIST model for complex Japanese characters. So these are the outputs for that. And if you go on to the advanced part, where in the advanced part, like I have used a multi-level classification for MNIST and the MobileNet algorithms. So in this, I used not encoding for this, like using a sigmoid function and to segment activation to classify the clothing type and other features, etc. So next if we go on to the expert level. So in the expert level, like I implemented object detection using SSD MobileNet v2 to built-in image system. So in this, for example, this is the layers which is identifying the cat and its output of the entire cat of it. So this is about the like image parts. And next we go on to the text model, where like in the text models, so the easy level, like I use the tokenizers and embeddings and the dense model for predicting the sample sentiments for this. And if you go on to the intermediate level, so intermediate in this, like I used a fine-tuned BERT model from TensorFlow from the complex sentence classification. So here is the output for that. And like after that, like I used NLTK for named entity recognition, like extracting names and locations from a paragraph. And if you go on to the like for example Apple, this is the example for that. And like in the last, if you go on to the expert level, this is a T5 model, like using Hugging Face transformers to generate like text summaries for this. This summarized output is accurate and concise, like it's just this much size, and it will be like concise to the the questions we ask for this. So this completes like all three of the parts, like explaining the like tackling the both part A and part B for the answers. And like I'll be pasting the video in this GitHub file.